extend a heartfelt welcome to you all for Keynote Session 1. Title: Monitoring of Meltmounts and Supra-Glacial Lakes over Nivlisen Ice Shelf, East Antarctica using spaceborne multispectral data by Dr. M. Geetha Priya at the IACESD 2023. I request Mr. Vishwanath sir to introduce the keynote speaker to the gathering.
Good morning to everyone. It was a very great moment for me to introduce Dr. Geetha Priya. Dr. Geetha Priya, an alumni of Anna University, obtained her bachelor degree in ENC, master degree and a doctoral degree from Anna University, Chennai, in the Faculty of Information and Communication Engineering. She is currently working as a professor at the Center of Incubation, Innovation and Research and Consultancy, Jyoti Institute of Technology, Bangalore. Her areas of research include signal processing, optical and microwave, remote sensing, GIS and polar cryosphere. She has more than 70 years of experience in different domains of academics and research with numerous research publications in a peer-reviewed high-impact journal to her credits beside 3 patent filings. Dr. Geetha currently has completed sponsor project from ISRO, Department of Science and Technology, Ministry of Earth Science, Vision Group of Science and Technology. Currently, she is actively carrying out research in the area of remote sensing, which includes polar cryosphere and disaster management studies. Dr. Geetha was a member of the Indian Scientific Expedition to the Arctic North Pole Summer 2019 and the 42nd Indian Scientific Expedition to the Antarctica 2022-23, largely funded by NCP or MOS and GOI, and became the first Indian team to fly UAV drones in the North Pole and South Pole to undertake remote sensing research activities. She has also extensively undertaken field visit in the Himalaya and Karakoram for ground truth verification. Besides, she is also a trained mountaineer, having trained at the Himalayan Mountaineering Institute and a trained UAV pilot. Her other activities include supervision of doctoral scholars, postgraduate and undergraduate students project. She is a life member of various professional bodies such as IET, IAENG, ISG, II, and has been reviewer for various journals and conferences. Thank you, madam, for accepting our invitation. Thank you.
Good morning, everyone. Can I get to know the background of you all? All of you are from civil background, isn't it? Can you throw some light on the background?
Computer science.
Okay, very nice. I think so. This suits much the conference theme because it is interdisciplinary now. Very happy for that. So I'm also from an EC background. Finally ended up in satellite image processing, and that's coming under remote sensing. Okay. So remote sensing doesn't belong to civil engineering alone, but it is a multidisciplinary where all of us have our part here. So you want me to speak very technical about this keynote address, or we will have some interactive session in understanding the work? We will interact. I'll make you to understand what is this research is all about, rather than talking very technical at a higher level what only PhD candidates will understand. Okay? I don't want to do that. Basically, you're all from bachelor's degree, right? Bachelor's degree in engineering. Okay, fine. Can you tell me what is you are able to understand from the title? Yes? You said we will be interactive. We see the ponds and lakes everywhere, even in Bangalore, in any part of India or the world, right? How it is different from the meltmounts and the supraglacial lakes? I'm audible, right, for all of you? Yes? Okay. I believe that you are all going to interact with me. So I'll be posing very basic questions about the work. Okay, it's not me who's going to give the keynote address, but it's you all going to deliver the keynote address to me now. Shall we make it in that way? Yes? Okay. So what is the difference between a pond and lake? Yes? Pond is small, lake is long. Okay. So, but the technical definition is pond and lake They are basically a water body only, but pond depth will not be more than 6 meters. Okay, but lakes, their depth will be more than 6 meters. So that will be the first difference. Second difference, ponds will be shallow, but lakes will not be shallow. This is a general definition what you get when you Google on what is a pond and lake over a Google. Okay, but the melt pond and the supraglacial lake, what I am talking here is something different. This forms only on the ice sheet. What is ice sheet? Where do you see ice sheet? Glaciers are different and ice sheets are different. Ice sheets we can see only in two places. One is in the Greenland, the next is in the Antarctica. But glaciers are present in both Arctic, Antarctica, Himalayas and many other places also. These melt ponds and supraglacial lakes can form on the glaciers too. Not only on the ice sheet, they can form on glaciers too. Okay? So, coming to the point, what we have done in this research work is, we are saying the climate is changing, global warming is happening, sea level is rising, correct? These are the three key things what we are seeing all around the world actually. Global warming, sea level rise and the climate change. And we are saying this climate change impact is very high with respect to Arctic and Antarctica. They are required to us. Do we need Arctic and Antarctica or not for our survival? It is very well required because they are regulating the global temperature. It contains loads of and tons of ice which is regulating the global temperature mainly. But what's happening is, because of the man-made carbon emission and greenhouse gases, many other things, global warming is happening at a higher rate, which is causing surface melting. The surface of the ice sheet or the surface of the glaciers are melting. So these melt waters will form on the depressions. They pond on the depressions. So we call them as melt ponds. When they get stretched for several meters or kilometers, and when the depth increases, we call them as supraglacial lakes. Supra means something on the top surface, superficially present. Okay? So that is the difference between a melt pond and a supraglacial lake. So we have carried out this research work on the Nivlisen Ice shelf. First you should understand what is the ice shelf is. Ice sheet is different and ice shelf is different. If you take Antarctica continent, ice sheet is spread across the continent and the ice sheet moves. Once the landmass is over, still the ice sheet will extend over the ocean, forming the shelf. Ice shelf means it is actually hanging, one edge is hanging on the ground and the other edge is hanging on the ocean. It is floating over the ocean but still attached to the landmass. So that is known as shelf, ice shelf. Okay. Instead of having two technical terms, just I'll tell you, this, because of the melting, melt water accumulates and they form ponds. Our objective is to find out in what capacity these melt ponds are all forming, what will be the size, the statistics, how much melt water is being collected, what will be the volume of this melt water, how these ponds are getting filled or getting drained. Can you tell me how a pond or a lake will get drained? Yes? There will be some outlet through which it will drain, or it will get dried up when the temperature is high, correct? But that is not the scenario when you take it, when it comes to the Arctic or Antarctica. What happens is, during the daytime the temperature will be around -1, -2. Sometimes it may go up to 0 degrees temperature. 0 is still sub-zero only. So what happens is, it will melt, it will refreeze. We call this as freeze and thaw. This process we call it as freeze and thaw. Okay. So significance, you can see the melt ponds and the lakes over the Nivlisen Ice shelf. So this is the Antarctica continent, which is divided into two things. West Antarctica as well as East Antarctica. So we main focus is on the East Antarctica. For Government of India, we have two research stations, permanent research stations in Antarctica. One is named as Bharati, other one is named as Maitri. So there are two research centers being run by Government of India, which are 3,000 kilometers apart. So we have one station at this point, another station at this point. So this is Maitri and this is Bharati. So whoever wish to carry out research work at Antarctica, we have to submit a proper proposal to Government of India. So if there is some merit after defense, they will provide you the logistical support to go to Antarctica to carry out the research. So that is how we got the opportunity for last year, and this year also we have got the opportunity to go to Antarctica to carry out the research. Coming to the point, what color you are seeing for the melt ponds in the figure? What is the color that you are seeing? White. I am seeing the melt ponds and the lakes in the color of blue. Are you not seeing the same? Yes? So this is the main difference. A melt pond will be looking in the blue color actually. When the surface starts melting, it is the first layer of snow that is getting melted. Under the snow there is ice, bare ice. So the blue ice is getting exposed through the melt water. So when you see a melt pond or a supraglacial lake over Antarctica, it will be appearing in blue color. Okay. Have you seen many of the houses in the older times being painted in white color? What is the reason behind that? Yes? Anyone else? White color has the capacity to reflect back the sunlight. That is the solar radiation that is coming. Right? So that is the logic. Anything that is white in color have the capacity to reflect the solar radiation back. Earlier, cricket players were using white color t-shirts only, but later on, because of the promotion and many other commercial activities, their shirt color has changed to different colors. Okay, so the ideology is when the snow is white in color, it has the capacity to reflect all the solar radiation back. So less melting. Did you get the point? Less melting. But what is happening nowadays is, because of this melt water getting collected in the form of pond and lakes, it appears blue in color. So they don't have the capability to reflect back the sunlight. Inversely, what is happening is, any surface that is dark in color is going to absorb more solar radiation. Black color absorbs solar radiation. Are you aware of this? Yes? So predominantly black absorbs. It's in general, any dark color is going to absorb solar radiation. So this blue color, it is absorbing more solar radiation and enhancing the melting. So that is what is happening. So more melting, the more dangerous scenario that is going to set because of this melt ponds and supraglacial lakes. Okay, so we have put some satellite images here. You can see Landsat 8 image, which is acquired at an interval of 15 days. You can see the melt ponds with melt water on the first time, and on the second time, after 15 days of interval, the water is not seen there. Two things. One is refreezing is happening. Second thing is this melt water is getting drained through the internal cracks. Okay. It's not a good thing for this melt water to get drained through the internal cracks, because I'll be showing you in the next slide what will be the consequences if these melt waters are getting drained through the internal cracks. You can see at the different time frames what has happened for the melt water. You can see here, there are two different water bodies. Over the course of time, this pond, it is overflowing and makes a channel and connects to the second water body. And after some time, they both refreeze and also the water gets drained. So this is keep on happening during the summer time. The summer for us is actually May, June, July, right? No, July is monsoon. Okay, April, May, June. But in Antarctica, the summer is during December, January, February. We call it as austral summer. The normal summer and winter is only for the people who live in the tropical region actually, for us. But for Antarctica, when we have summer, it is winter there. When we have winter, it is summer at Antarctica. So that's why we use the terminology austral summer and austral winter. So austral summer means it is December, January, February. Okay. So before going into the technicalities, just I want to tell you why we have to monitor all this. This ice, this melt ponds are a threat for the shelves, ice shelves. Ice shelf is very important for the Antarctica continent, because when the ice is flowing, ice will definitely move. The ice sheet over the Antarctica continent, it will definitely move because of the equilibrium. When it is moving, it will fastly approach the ocean. So what happens? The sea level will rise. So already I mentioned about the sea level rise, which is a threat. These shells will be applying a buttressing effect. What is buttressing effect is? It is going to offset the velocity at which this ice sheet is moving. So it is very important that we monitor this melt cones to ensure the stability of the ice shells. Yeah. So this is what exactly I was telling to you. If the melt cones are formed because of their bright color, more solar radiations will be observed. You can see it is getting enlarged. The water bodies are getting enlarged, more meltwater is being collected. So this is going to create a positive feedback enhancing the melt. Second thing is, if the meltwater is draining through the internal cracks, this will finally going to result in hydrofracturing of the shell. Finally, the basal melting will result in the calving of the ice shell. You can see how the basal melting is resulting in the calving of the ice shell. If all the ice shells are going to diminish or going to disintegrate like this, it is not a good sign, because this is going to result in higher velocity of ice sheet movement that is finally going to increase the sea level rise. Yeah, here we go. You can see the Antarctica continent shapefile, the landmass, started with the ice shells. Whatever you see in yellow color, they are all the risk maps over the shelf region. Across the entire Antarctica, we have more than 50 ice shelves actually. So as I mentioned earlier, Indian government is having two stations. One is near the Emery Ice Shelf and one is near the Nivlisen Ice Shelf, which is shown as NIS and AIS. Anybody who wants to go from India to Antarctica for research purpose, we can have access to either NIS shelf or AIS shelf. AIS is Emery Ice Shelf, NIS is Nivlisen Ice Shelf. So we have put the outer boundary of the Nivlisen Ice Shelf, and there is a small oasis here over which Maitri research station is located. So I am not going to get into the methodology details, but what we have done after going to Antarctica, I will let you know. We have collected the satellite data sets which will cover the Nivlisen Ice Shelf, from which we have monitored, delineated the melt cones and calculated the statistics of it. Apart from that, we have flown UAV to collect some sample data sets over the melt cones on a regular frequency actually. Nearly 22 years of satellite data we have collected over the Emery Ice Shelf. You can see the small patch of water body, how it is changing over this time period. Only one water body we have focused. So over 22 years time frame, how it has evolved and what was the length and the width of the water body, you can see here. So when we developed a model to estimate the depth of the melt cone, we have seen that maximum of 6 meters, the depth was maximum of 6 meters. So this was accumulating nearly 17 into 10 to the power 5 cubic meters of water actually. So during the field season, we deployed an instrument over the melt pond actually. So you can see where we are sitting. We have installed the setup. Actually, this is the middle of the melt pond. Before the onset of summer, we went there for this installation purpose. Before melting only, we have drilled up to 3 meters under the ice. So total setup height was around 5 meters. You can see 2 meters above the ice. 3 meters is still under the ice actually. So this was basically a pressure transducer which is capable of measuring the hydro pressure. The idea was to measure how much amount of melt water is being accumulated in a given pond. Okay, so that was the idea. Okay, so for UAVs we were in need of some ground control points. So civil students, you know what is meant by ground control points and what is the importance of it. So it is really required if you have to ortho-rectify the UAV derived images properly. So using checkerboards we used it as GCP and we put it over the stable regions to collect the GCP points. Okay, so you can see after melting how is the condition. This is before melting. The first picture shows on the 1st of December and within 22 days how much melting has progressed you can see. So almost 2 to 3 meters of water was there. So when the melt was progressing, it was very easy for us to collect the data from the center. So So we go just open it. You can see in the previous slide. There was a data logger. This is the data logger actually. So we have to open the box, take the data logger, connect it to the laptop and collect the data. But after melting, it was very difficult to go inside. You have to wear a swimsuit. I mean, for your understanding, I mentioned it as a swimsuit, but actually it is an immersion suit. The immersion suit weight is around 20 kgs. It's very bulky. You have to wear it and get inside the pond. And still it was very deep. So we attempted 2-3 times to get into the pond to collect the data. So, but it was very difficult. So later what we did is, we made a wireless communication system to collect the data from the melt pond actually. So LoRa is long range transceiver device. So using that we configured the pressure transducer. So whatever data it was collecting from the pond, we were able to get it in a wireless mode to the station itself. Okay. So after the data has been retrieved, we were analyzing the data. You can see that in the graph there are two lines. One is pink, which is showing the hydro pressure. The blue one is representing the temperature. You can see the surface temperature. Are you able to see? Because of the resolution problem, I think you are not able to see the values. But the temperature has gone up to 20 degrees Celsius. The sensor was configured to collect the temperature and hydro pressure for every 15 minutes. So it was like 24/7, it was collecting the data for every 15 minutes. So analysis of the data is showing all the time the temperature, the surface temperature. I am not talking about the air temperature. Air temperature will be always cool, it will be chill enough at -1 or -2 degrees. But this was at the pond bottom surface. So it was up, maximum it went up to 20 degrees Celsius. That time when I had a communication with one of my students in the lab, he said Bangalore is much colder than Antarctica. So that was a statement actually. So we were actually surprised to see this higher values. What we did is, we started doubting ourselves and our designs actually, whether this value is possible. So we contacted IMD. IMD is Indian Meteorological Department. So there are 3 scientists who were working at Maitri station for some other purpose. So they came with their devices, which is approved by WMO. WMO is World Meteorological Organization. So they came with their device and they cross-checked whether the temperature measurements done by our sensor is it same as what their equipments are measuring. Luckily, it was the same. So you can see, this is on the surface of the ice actually, the temperature what it was showing. So we kept our sensor and their measuring instrument. Both were showing exactly the same temperature, so there was no variation at all. So that way we were really happy that we are not presenting any misclassified results or anything. So it was correct. Really 20 degrees Celsius of warm water was present in Antarctica. So that is the fact. And this slide is showing 9.7. That is the ice temperature. Ice temperature it was showing as 9.7 degrees Celsius. It is actually a pH meter which gives the pH value as well as the temperature. But it will be on a stretch, it will be on for only 5 minutes because of the battery constraint. You know that in Antarctica the battery drains very fast because of the colder temperatures. So if suppose luckily if the instrument was working for more than 5 minutes, definitely the temperature might have gone even up to 12 or 15 degrees I believe. Because it was slowly increasing. When it was showing 9.7, I took a photo of it. After some time, it got switched off because of the battery drain. Okay, so I said we were also doing some aerial survey using multispectral data. So this is the sensor what we use. It is parachute sensor, which is costing around 4.5 lakhs. So it can acquire the image in 6 different bands, 6 different multispectral bands. Okay, so some glimpse of the UAV survey results. You can see the evolution of the melt pond. So we started the aerial survey sometime in the last week of November because the cargo we sent it to Antarctica in the month of September, but it reached Antarctica by November. So after we got it, we started our survey. We did nearly 19 surveys, out of which 10 samples turned to be very good. The remaining samples, what was the issue? There are a lot of issues if you have to fly a UAV in Antarctica. It's not an easy task. The moment you start your drone, immediately the battery shows 70 degree. Then within 2 minutes it shows 50 degree, 50%, etc. can see how the lake is getting expanded and how the depth is also varying. So this is only for one lake, one melt pond where we have set up the hardware pressure sensor assembly. So the depth, area and the volume gradually increased following a perfect Gaussian bell-shaped curve. You can see it started slowly increasing and hit a peak, then started coming down. So why did the volume come down? Why did the area come down? Why did the depth come down? Can anybody tell me? Just guess, wild guess, vague guess. Yes? I already mentioned there is something known as freeze and thaw process which will be happening. Whenever the temperature goes above 0 degree temperature, it starts melting, which we call it as thawing process. Later when the temperature comes down in the evening time or so, it gets refreeze. So it gets freeze. So freeze and thaw was happening throughout the day and for the entire period of summer. So later what happened is through the internal cracks and through some supraglacial channels, the water started draining, due to which the volume of water came down, the depth of water came down, and finally our last survey was on January 6th. By the time completely the lake got frozen and it was completely buried under the snow. Okay, this is the glimpse. You can see how many such melt ponds are seen actually. This is just a 75 meter by 65 meter drone image over which you can see hundreds of melt ponds. In the previous slide, I showed you only one melt pond which we continuously monitored for a period of 1.5 months. But you can see such ponds, hundreds of ponds you can see only in a smaller region of 75 meter by 65 meters. So if we want to monitor all the melt ponds and to find out how much volume of melt water is being drained through the internal cracks or getting melted through every austral summer, then we have to depend on the satellite data only. So satellite data, we can surely cover up to 230 kilometers swath in one stretch. So this is what, these results have been derived from satellite data sets. You can see the entire Nivlisen Ice shelf we have covered and more melt ponds were found near the grounding line. So you can see the variations. So during December we can see only a small trace of water bodies. Then during January more melting. So water bodies are mapped. Then we apply the model to estimate the depth of the melt ponds. So maximum of 6 meters of depth was found during the austral summer. So some of the glimpses of the satellite data results. So throughout the entire austral summer of 2022-2023, we have carried out the work. Yes, so I have come to the end of my presentation. If any doubts you have or anything in specific, if you want to know about the logic or the technicality of the presentation, I will be happy to explain to you. Any doubts? Yes? No doubts? I hope I didn't bore you. Okay? Okay, thank you all.
Sessions. We are humbled by your presence of Dr. Geetha Priya in AICESD 2023. Thank you for sparing your time for sharing your key message amongst us. Now I request Dr. Madhusudan sir, Head of Mathematics Department, to felicitate Geetha Priya on behalf of Jyoti Institute of Technology, Bengaluru. Thank you, sir. We are sure audience have found this session very valuable and informative. Thank you, ma'am. We are humbled by the response and thank you for your active participation.